We wanted to try out the nitration of vanillin, but we couldn't find a procedure. So we figured we'd have a go at making one up. Vanillin is a phenol, so the aromatic ring is pretty activated towards electrophilic attack. So nitration should be pretty easy. With phenol, for instance, dilute nitric acid will nitrate very readily. We did try mixing vanillin with some fairly dilute nitric acid, but the resulting reaction seemed very vigorous indeed. We were also not sure if the vanillin reacted completely as it's insoluble in water. So let's try something different. Here we've weighed out 25 grams of vanillin powder into a 250 ml beaker. Let's get a stir bar in. Now we're going to dissolve the vanillin in a solvent. We're going to use dichloromethane because it dissolves it fairly well, and also because it shouldn't react with the nitric acid we'll be using. Here's about 50 ml of dichloromethane to start with, but as you'll see we needed a bit more than this. So let's get this in. And now we'll get this set up on a magnetic stirrer, and start stirring. As the vanillin dissolves, it cools the mixture quite strongly, making it less soluble. We want the mixture cool though, so we need to add enough DCM, so we've got a chilled solution. About 130 ml of total volume, and nearly all dissolved. So now we get this set up in a cooling bath of ice and water. The nitration will be exothermic, and although DCM boils at 40 degrees C, we don't want this boiling everywhere. This is happily chilled down now, so let's prepare our nitrating agent. Here we've measured out 20 ml of 68% concentrated nitric acid. In theory about 16 ml of this represents a 1:1 molar ratio to the vanillin, but we'll see how much we need to use as we go along. Let's get this into a beaker so we can add it dropwise to the reaction mixture. So let's try it out. There's an immediate yellow color produced, and the aqueous blobs in the stirred mixture turn red. We'll keep adding slowly. Another thing about dichloromethane is that nitric acid is pretty soluble in it. Although there's some water in the nitric acid we're adding, it's likely that some of the pure nitric acid is passing into the DCM layer containing the vanillin. Soon we've got a yellow-orange colored precipitate forming, and the mixture is a red color. The temperature is under control, but we notice that if we add more than a few drops of acid at one time, there's a slight bubbling of the reaction mixture. We left a few ml of the nitric acid behind, probably adding about 16 to 17 ml in total. Towards the end we couldn't see any more exotherm, and there was a tiny amount of brown nitrogen dioxide gas being produced. So we left the mixture stirring in the ice water for another 30 minutes. And then allowed it to warm slowly to room temperature with stirring over another 20 minutes. Next we measured out 45 ml of water, and added this to the mixture. And then we chilled down in the fridge for a couple of hours. It's certainly a very pretty reaction mixture. Here we go after 2 hours of chilling down. Quite a bit more precipitate has formed in the bottom DCM layer now, so we're going to filter this now and see what we've got. We wash the beaker out with cold water. and then wash the yellow solids carefully with cold water until the filtrate was only a pale yellow color. And then we dried the solids as best we could on the pump. Okay, here's what we've got. It's quite fluffy but not completely dry, but it's 36 grams of yellow product. So there's definitely some kind of weight gain as we'd expect from a nitration process. But we're going to have to purify this in order to see if we've actually got 5-nitrovanillin in here. We did find a reference to this product being able to be recrystallized from hot ethanol, so we figured we'd give this a go. Here's 10 grams of the yellow crude product. We're going to see if this will dissolve and recrystallize from ethanol. Let's get this into a larger beaker on the hot plate. And now we'll start adding ethanol, washing the weighing beaker first. Let's start heating. Soon we've got some bubbles appearing as the ethanol starts to boil. Well, it's obviously not that soluble, so we'll need to add some more. Getting hot again, and it's still not very soluble. Okay, let's go nuts and get 200 ml of ethanol in here. Some of the solid has definitely dissolved, but lots remains. Either because it's not very soluble, or perhaps because it's an impurity. So let's leave it to settle, decant off the ethanol solution, and then chill this down to see if we can get crystals. Sure enough, on chilling down we're getting crystals forming. We've noticed that this stuff likes to form on the glass. So let's filter. We've got some purified product, but out of the 10 grams we put in only 2.4 grams of crystals. A lot of product still seems to be in the ethanol filtrate, so it looks as though ethanol isn't a great recrystallization solvent. We also tried with acetone and got a similar result. Unfortunately we've run out of chloroform, but we've got a hunch that this might work well, but we'll have to do this in the future sometime. But we do have some nice microcrystals here of what seems to be a pure product of some sort. So let's see if we can do a test to find out if it really is 5-nitrovanillin. First up, let's try to burn the sample. It melts at fairly high temperature, much higher than vanillin, and then burns quite vigorously, leaving a spongy mass of carbon behind. Okay, well that's interesting. Now we know it's not going to explode. Let's try something a bit more controlled. We've rigged up a slightly dodgy melting point apparatus using a hot plate, a test tube sitting on it, and a thermometer inside the test tube to record the temperature. It's not going to be totally accurate, but it will give us an indicator. We've got the heat on and the temperature is slowly rising. We'll watch this closely to see if there's any signs of the product melting. (110°C). Still no sign of melting, so it's definitely not vanillin. And here's our first sign of the solid starting to melt right at the bottom of the tube. This happened at about 162°C according to the thermometer. Now continuing up, and we're definitely getting a liquid formation now in the tube. The temperature is nearly 170 degrees C. The temperature difference up from the hot plate means that we can't get it all to melt. And this shows why our temperature reading is likely to be on the low side if anything. But we've got the dark brown colored liquid in the bottom now. So our recorded melting point started 162 degrees and went up to 170 degrees C. The literature value for 5-nitrovanillin is around 175 degrees C. So it's really not far off. So we're going to tentatively assume that that's what we've got as a recrystallized product. We've got about 5 to 6 grams from the various attempts we made, so enough for some follow-up reactions. And we'll keep experimenting to see if there's a solvent which works better for recrystallization. So this is a reasonable process. As we said at the start, you can't try to do this in aqueous solution, but you obtain the dark-colored product with a lot of impurities and it seems very difficult to purify properly. So stay tuned. We will be on vacation for 5 weeks starting in about a week's time. We might be able to publish a few videos, but wait and see. Just advance warning.